Hey everyone. So let's get started. Today is day 7 for our class for Math 133. I sent a link in the chat. I also sent it in Remind for this very short one question survey. How do you plan to take the midterm? So uh, if you haven't decided yet, that's fine. You can click I don't know yet. And if you select one of these and you're like, and later you're like, oh no, I need to change my mind. That's totally fine. I just need this so I have an idea how many tests I need to send to the testing center. So if you're going to do it in the testing center, but you haven't picked a day, just select this one. But um, anyway, so if you're doing it with me, that's fine. These are the times. So if you're taking it in the morning, Wednesday, June 25th with me, we're going to start at 9 a.m. and we're going to go till noon. Okay. The exam is long enough that you should be able to finish it in 2 hours. But if you need a little bit more time, I'll be on for 3. Um, if you think you're going to need more time than that, you'll want to do it in the testing center. Okay. The testing center, uh, you'll have unlimited time, okay, as long as they're open. Um, if you're doing it with me in the evening, that's where you guys are right now in the evening class, Wednesday, June 25th. We're going to start at 6 p.m. We usually start at 6:30. We're going to start at 6 p.m. and we'll go until 9. Okay, so again, 3 hours should be enough time. Okay. But once we hit 9, we're done. So if you are worried you're not going to run out of time, or if you're worried you're going to run out of time, you can go to the testing center on campus. I mean, you guys have been in school for what, like 13 years, so you know whether you're, good at taking tests, or if you need more time or not. So if you feel comfortable with this material, where you're looking at the reviews and you're like, yeah, Joe, I already know how to do all these. So then you're good. You probably, don't need to go to the testing center. So we will be doing a sample midterm. Um, but that's going to be a little bit longer than the normal midterm. So today's day 7. Our sample midterm we're going to work on June 23rd, and right before the exam. It's pretty big, so it's bigger than the actual exam. So just FYI. Um, so I said something wrong last time. I said that chapter 5 was the end of the material on the exam. Cindy corrected me. Chapter 6 is on the midterm exam. So previously we were going to cover chapter 6 after the midterm. So you can see right here we were going to do it on June 30th. Well, that doesn't make any sense. We need to cover it before. So I rearranged some things. I got rid of a project. So I'm adjusting some things. So today we're going to cover chapter 4 review and a cumulative review number 2. Next time we're going to do chapter 5, cumulative review number 3. And then I'm going to be gone on the 18th, but Cindy is going to cover the chapter 6 review for you guys. And if you have time, if you get done with that, you can start working on the sample midterm. Are we on day 7 or day 8? We are on sorry, yes, we are on day 8. Oh my gosh. Thank you. Yes, we are doing day 8 stuff. Yeah. Um, oh my gosh, get all my days wrong. Okay, so these assignments that we're doing today, chapter 4 review, cumulative review, these will be due on Monday, the 16th. Yes. Okay, so everything up to the midterm I've rearranged. I've changed the due dates and everything like that. Uh After the midterm is still wrong. Because we're not going to cover the chapter 6 review on the 18th and the 30th. That's crazy. So I need to change a few things, move things around. After the midterm will actually be not quite as fast paced, hopefully. Anyway, so if you are working ahead, the lecture notes are all accurate. It's only the projects and the worksheets that I got to rearrange. So if you have already done 5.2 lecture notes, great. If you've moved on to other lecture notes, that's fine too. The lecture notes, like I said, all of those due dates are accurate. So, okay, cool. So, um, make sure you fill in my I mean, it's not for points, but it really would help me if you can tell me your midterm plans. Um, Today is day 8. We're going to cover the chapter 4 review first. So chapter 4 review is in your course pack, and it's on page 332, page 332. Um, but you'll also want to click in Canvas chapter 4 review worksheet because there's one question that's going to use StatCrunch. So if you click on in Canvas, if you click on the chapter 4 review worksheet, there'll be a link that you can click on that will take you to StatCrunch. So you click on that, and that's going to take you here. Make sure you sign in. And actually, it's going to take you to this one. So, but make sure you sign in. It's just the data set for question number 3. Uh, okay, so going back to page 332. Uh-oh, that's not zoomed in. There we go. That looks better. Um, can you guys see my screen okay? I got a nod from Cindy. Okay. It was a little blurry for a second there. Yes, thank you, Dakota. Okay, cool. So, just like our other worksheets that we've done before, we are going to finish it here in class today, but I'm not just going to do it for you. We're going to work on them together. And before we do that, though, I'm going to give you some hints on the ones that you might get stuck on. So, some of the ones that I think are maybe a little harder. So, here we go. So, first question. The Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects were timed for complete paper pencil mazes multiple times while wearing masks. They completed the mazes 3 times wearing floral scented masks and 3 times with unscented masks. Participants were assigned at random to wear the floral mask during the first 3 trials or during the last 3 trials. Okay. So identify the explanatory variable. So explanatory starts with X, so that's my X variable, okay? And my response variable is Y, okay? So let's go back through this again. So the foundation conducted a study to investigate whether smell can affect learning, okay? So in this case, the smell is my X and the learning is my Y, okay? X is your dependent variable, your explanatory variable. So in this case, smell or scent. Okay. Your X is something you can control. We can control whether you're smelling scents or not here, depending on which mask we give you. Okay. We can't control learning directly. Hopefully, this study tells us that, we can adjust it based on whether you're using a mask or not. So, this is my dependent variable, so in this case, it's learning, okay? Uh, or it could be the speed that you go through the maze, okay? All right. Identify the treatments. Treatments are always going to be connected to the X because I can control the X, right? So it's going to be scented or unscented masks, depending on which one we give you, okay? All right. Hopefully that makes sense. Okay, so that's actually all of question 1. So we did the whole thing. So we'll do most of number 2 as well. Find out the correlation diagram. Fill out the correlation diagram fully, including arrows and boxes for the scenario in the cartoon at right. Okay. So the cartoon says statistics show that crime rates rise with the sale of ice cream. Now do your part and move along. Okay, so ice cream shop is closed. So, um, yes, it's a funny cartoon because we know that, okay, ice cream sales don't actually drive crime, right? There's not a bunch of hoodlums out there eating ice cream and committing crimes, right? So, it doesn't, it's not the sugar that makes you commit crimes, I guess. But anyway, so uh, for our X variable, they are saying that uh, these two things, ice cream sales and crime rate, are related. Okay, they are correlated or causation. So our X value is something we can control. We can't really control the crime rate directly. Okay, but we can control ice cream sales, right? If we sell less ice cream, if we close the shop, then the idea is we can change our Y variable, okay? Which in this case is the crime rate, okay? And this is actually true. Higher ice cream sales is correlated with the crime rate, okay? But it's not causation, okay? So these arrows, we have to label these arrows. So uh, higher ice cream sales, this is not causation. It's not what causes the crime rate. There is something called a lurking variable. Okay. All right. So what would our lurking variable be? And this lurking variable, you can see by the arrows, affects both of these. Okay. Um, so uh what is something that would affect ice cream sales? What causes, when do we have higher ice cream sales? The heat, the summertime, you got it. The weather, right? Any of those are fine. Weather, summer, okay. And actually, when it's nice out, crime rate is also higher, okay. So this is a causation, okay, where when the weather's nice, you're going to get more ice cream sales. When it's rainy, people are not out on the street. People are not out, to stealing things. Actually, I don't know if you ever heard it, but um, there's a saying that the best officer on the police force is the weather, is Jack Frost. So when it's cold, nobody's out, doing committing crimes usually. So I'll let you fill in the arrows here. But yeah, this is a lurking variable that would actually drive these two. So uh, the saying is correlation is not causation. Okay. All right. I think you guys can do this one, number three. So we'll move on to the next page, page 233, 333, 333. Um, page 333. Uh, this is looking at firearms and death rates for certain countries. Scatter plot shows the relationship between prevalence of firearm ownership and the death rate due to firearms in industrialized countries of the world. Okay. Um, so they give us the equation of the least squares line. Okay. So we don't have to calculate it ourselves. We will get a chance to calculate a couple today. Okay. They also give us R squared. Okay. That R with the little arrow there is R squared. Okay. Um, this, the x-axis, this is our x variable, and this is the units on it. Okay. This is our y variable, and this is the units for y. Okay. Right here in parentheses. Um, okay. Uh, how many countries were in this data set? So each dot here represents a country. So just count the dots, okay? And it's okay if it's not perfect. Some of the dots are on top of each other. Just get close, okay? I don't need it to be exact. Um, what type of data is the variable firearm death rate? So firearm death rate is a rate. So that means it is going to be a decimal. So Qualitative is usually going to be in words. Okay, it can be numbers, but usually it's words. It's descriptive. Quantitative always is numbers. Um, but discrete means it has to be whole numbers. So here I've got whole numbers. So 0, 2, 4, 6, 8, 10. So if you can only have dots that land on one of these whole numbers, that would be discrete. Okay. Continuous means you can land anywhere along the line, even decimals, even fractions. Okay. So in this case, rate is a decimal. So we are allowed to have decimals. That means it's continuous. Okay. An example of a discrete one would be if we were counting the number of deaths, not doing a deaths per 100 people or 100,000 people. If we were saying total number of deaths each year, you can't have, you can't be half dead. Okay. Um, so you can't use decimals there. That would be discrete. What is the coefficient of determination? So coefficient of determination is r squared, okay? And they gave that to us, 0.773, okay? That was nice of them. Interpret what the coefficient of determination, so the r squared, means in the context of the situation. So on page 233 in our course pack, there's a script that explains what the coefficient of determination is. So page 233 is all about chapter 4, okay? And R is the correlation coefficient and R squared is the coefficient of determination, okay? So it's easy to get those confused because, I mean, they both say coefficient, one is R squared. But the good news is this page 233, this is part of the yellow packet that you can use on your exam notes. So you get to take this to the exam. So if if the question is about coefficient of determination, you can look here and see that we're talking about R squared, okay? So the interpretation of coefficient of determination is this script down here. So you take your r squared, you multiply by 100, and that gives you a percent. So something percent. So my r squared is 0.773. That's a decimal. Can you give it to me as a percent? Multiply by 100, please. 77.3. Thank you. Thank you, Nancy. So 77.3% of the, I'm just going off this script, total variation in our Y value. What was our Y value? So our Y value was firearm death rate. Okay, so that's our Y value. So 77% of the total variation in Y is explained by the least squares. So is explained by the least squares regression line. Okay. All right, great. So that's the context of the situation is we're talking about the r squared, and we have a script that explains what r squared means, okay? All right, cool. So the next one, calculate the correlation coefficient. That's our r, okay? So to get that, you need to take your r squared and get rid of the square. The way that you get rid of a square is you square root, okay? So that means you're doing the square root of 0.773 in Desmos. So I'll let you guys calculate what that is, okay? Now, one important thing to note with R can be positive or negative. R squared cannot. When you take in a negative number and you square it, it's always positive, okay? So if you go backwards and you take your R squared and you try to get to your R, you might get a positive, you might get a negative, but you're not going to get that out of Desmos. You have to use your own brain and figure out if it's positive or negative. So the slope of this line is always going to give you the same sign as your R. Okay. Slope meaning if I start on the left and go to the right, am I going up or down? So if I was on this line and I was walking along it, we always read left to right, and so we walk left to right, I would be going up. So it is a positive number in this case. If this was a negative slope, I would take whatever I get in Desmos and just put a negative in front of it. Okay. Okay, so I'll let you, do some Desmos for that. Okay. Um, all right, I'll let you do this. By the way, the explanation for calculating an R is on page 109 of our course pack. Okay. So, all right. Uh, let's move on to page 334. Okay, so we're still going to be talking about the same graph, so don't throw that paper away just yet. Continuing with the firearm data, what is the regression equation? Um, I'll let you do that one. What is the slope of the linear regression? Interpret the slope. So interpret the slope in the context of the situation. So same thing, page 233 in your course pack has a script that explains both, it explains the coefficient of determination. We looked at that. There's also a script that explains slope. Okay. So the slope, the interpretation of that is if x increases by 1 unit, then y is expected to increase or decrease by approximately slope with units. Okay. So you're going to write that out exactly as it's written here, except you're going to fill in what x is, fill in what the units are, and so on. Okay. Um, okay. Now that's for slope. Okay. Uh, you'll remember that a line, the formula for a line is y equals mx plus b. Okay. So they gave us the line, they gave us the formula. So y equals, this is actually our b plus slope x, mx or ax. Okay. The slope is always the number that's attached to the x. Okay. So maybe it would have been better if we'd written it the other way around. Okay. But that's fine. So the slope has an interpretation. As x goes up by 1, y goes up by how much? Okay. The y-intercept it has an interpretation, okay? And you can see it here on page 233. When the x is 0 units, y is expected to be approximately something with units, okay? But usually your y-intercept isn't useful, okay? You can't really do much predicting with the with the y-intercept, okay? Whereas you can with the slope, okay? So this one, explain why the y-intercept does not make sense in the context of the situation. So there's no script really for this. You have to just use common sense, okay? Sometimes it does make sense, okay? Sometimes um, if it does make sense, you can use the script that's on page 233. But if it doesn't, then you have to just, use common sense and be like, this is why you can't really, estimate that. Okay. Um, don't forget to include units on all of these, okay? Don't forget units as you're going through, okay? Residual is also on page 233. We're all up into page 233 today, okay? Um, okay. Firearm death rate we said was our y-axis. So if y equals 2.0, you'll have to solve for x on this one. Okay, so you're gonna have to do some algebra. Okay. Um, that's those are all the hints for that page. Uh, okay, last page for the chapter 4 review. Now, okay, so uh, hopefully we can move away from talking about um, something bad, firearms and death rate. So Oh, no, it's cholesterol. Never mind. So, still a bad topic, but that's okay. Um, so a doctor wants to see if a patient's BMI can predict whether their HDL cholesterol and they collect the following data from a random sample. So this random sample is in StatCrunch. So that's what I asked you to click on. So you clicked on Chapter 4 review worksheet. You clicked on the link. It brought you here. You signed in, and now you can do some StatCrunch stuff. Okay. So the steps that you'll do for that are on page 233. Okay. So let me jump back over here. So, StatCrunch is page 233. Okay. And when you do linear regression with StatCrunch, I'm going to put a star right here because it's going to help us get a whole bunch of things. So it will get us the sample size, it'll give you the regression equation, it'll give you the slope. Okay. Um, uh, it'll give you the correlation coefficient and the coefficient of determination. Okay. So I put a star next to everything that StatCrunch is going to answer for you. Okay. Um, right. Uh, for this one, um, there's not really a script, so just use logic here. Okay. Basically, uh, yeah. Okay. I think that's probably good. So for this one, you have X. You have to find what Y hat equals. Okay. Um, when we talk about Y or Y hat, right? When we say like Y equals MX plus B, but sometimes we put a hat over it. Um, the hat just indicates that it's an approximation, it's an estimate. So linear regression is an estimate. Okay. If I look at the line that we were looking at earlier, um, you'll notice that the dots are not all exactly on the line. Okay. Some of them are, some of them are close to the line, some of them are kind of way off. Okay. Um, so that's with linear regression, you are estimating the trend. Okay. And that's why we use y hat because it's not perfectly accurate. It's a prediction. Okay. So, all right. So that's the chapter 4 review. We're not going to jump in just yet because we have another worksheet to cover tonight, which is the cumulative review. And I want to give you some hints on the cumulative review as well. It's probably easier if I give you all the hints now and then we dive in and solve all these problems as opposed to pausing in the middle, going back and doing hints. So, okay, this cumulative review, this is the one that goes from chapters 1 through 4, and it is on page 377 in your course pack. Page 377. So the next cumulative review will cover chapters 1 through 5, but chapter 6 is still on the midterm. Okay. Okay. Um, and this one's this one's no problem. You guys can do this one on your own, I think. This one, by the way, right here, uh, these two numbers should add up to 100%. That's my hint for you on that. Okay. That's kind of a big hint. Oh, please include your name on these worksheets. It really helps me as we're grading um, if it's on there when you submit it. Okay. I appreciate it. All right. Um, all right, page 378 is a project that, very similar to the chapter 2 project stuff that we've done before. But we're not going to do this, so we're not going to submit this project. It's not required, but we are going to have to fill in all these numbers just the way that we've done before. Okay. So, um, but you guys can do that. We've done a bunch of those. So, how many means frequency, right? That's a count. But when we ask what percent, percent is relative frequency. Okay. Um, okay. um, I'll let you guys fill that in. This one right here, is page 232, method 2. Okay. In order to get the mean and the standard deviation. Okay. And then down here, there's a script. It's the give or take script on page 231. Okay. Okay. So this one also, method 2 is in StatCrunch. So going back to Canvas, our cumulative review worksheet number 2. If you click on that in Canvas, there is a link that brings you to the StatCrunch that has the data for this. Make sure you sign in, and it's going to bring you here. Okay. Okay. All right. So there's that. So that's, man, we had some rough topics tonight. Firearm death rate, cholesterol, binge drinking. Uh, Here's a good one. We have baseball to talk about on the next page. So, um, page 379. Uh, the following data set gives the batting average, and runs scored for a random selection of professional baseball players in the 2019 Major League Baseball season. Okay. Um, so this is chapter 4. Okay. So we're all about page 233. Okay. Gonna really help us. Okay. Um, so uh again, we're gonna use StatCrunch and what you're gonna and this is actually gonna be in the same StatCrunch file right here. I have batting average and runs scored. So StatCrunch, the instructions on what you click on are on page 233. And then that's going to get you this answer. It's going to get you um, uh, this answer. What else is the StatCrunch going to give you? It's going to give you the linear regression. It's going to give you the slope. Okay. So, if you haven't gotten StatCrunch yet, we have at least one person that hasn't had a chance to get into StatCrunch. This is where you really need to make sure that you're able to get in. Okay, so message me in Remind or talk with Cindy, and we can set up some time and make sure that you are able to get into StatCrunch. I mean, you're going to need it for the exam as well, but we need it for these worksheets too. So. Um, correlate coefficient of determination is R squared. Correlation coefficient is R. Okay. Um, and then uh for interpreting the coefficient of determination, you'll find that on uh page 233. There's a script for that. Okay. And then same thing for slope. What interpret the slope in the context of the situation. So same thing, page 233, there's a different script for slope. Okay. So yeah, so these batting averages, 20.3%. Usually when we do talk about batting averages, they multiply it by 1,000. So like if you're batting 1,000, that's the same as 100%. So this would actually be 203. So with percents, we move the decimal 2 digits. With batting averages, we move it 3 digits. That's fine. Percents are easier to understand, so we're going to do percents. So, all right, one more page. Oh, it's still on the baseball stuff. Okay. So the last page, and then we'll dive in and do some work. So what is the y-intercept of the regression equation? Remember that a y-intercept is not just the b value, okay? So, and StatCrunch will give you this. It's not going to give you this part, okay? Um, so you need two numbers here to give a y-intercept, okay? Um, and so explain why this does not make sense. If it does not make sense, there's no script. You just have to use common sense. Okay. If if it if it does make sense, then fine. Okay, there's a script, but um okay. Uh this one, there's no script for this either. Use logic. Okay, there's no script for this. Um, right. So if x is 24.9, using the linear regression equation, interpret these values in the context of the situation, be specific. So basically, a player with batting average of x and x units uh, expects to score blank blank. Okay, so all right, that's probably enough. Um, Residual. There is a formula for that, and you guessed it. It's page 233. Um, okay, so this one, our y is 57, and you need to solve for x. Okay. All right. Last one also has a script, and it's on page 233. So suppose an expert talking on ESPN claims that a higher batting average is the cause for more runs scored. Explain why this reasoning is not correct. So the script we're looking at for this one is correlation is not causation. Okay. It's a common term that we use in statistics. So it says right here, correlation is not causation because there are lurking variables such as blank that are affecting the variables. And so that's literally what we're going to type right here. Okay. Correlation is not causation because there are lurking variables such as, and then you guys are going to list some of the lurking variables here that affect both the batting average and runs scored. Okay. So give me one or two lurking variables that are going to drive batting average and runs scored. And that's actually what's, maybe causing the correlation here. Okay. All right. That's it for my hints. So I'm going to stop the recording and then we'll split up in some groups and we'll do some worksheets. Okay. Um,